Welcome to Chapter 17, Section 3. This is Part A. We're going to be defining current and resistance. So what we're going to do in this section is we're going to describe the basic properties of electric current and solve problems relating to current, charge, and time. And we're going to calculate resistance, current, and potential difference by using the definition of resistance. We'll save this one for Part B video. So current, what is current? Current is just the movement of any charge at any time. So anytime you have some charge, Q, whether it's plus or minus, if it moves in any direction for any reason, then what you have is current. Okay, and it can just be one charge or it can be many charges. So current is responsible for many useful technological things like lights and all electronics. Current is also responsible for biological things, okay, like our nerve endings, all the messages in the brain and those sent to and from the brain and the rest of your body use moving charges. So our bodies really work because of current also. However, we're going to stick to just electric current for class. So electric current specifically is the rate at which charges move through a cross-section of wire. Okay, so cross-section just means if we cut this wire, we cut it there, how the charges move through it. Okay. So one thing we need to look at is conventional current. So conventional current is defined as the flow of positive charges. But remember, we've been talking, and in wires, it's actually the electrons that tend to be in motion, okay, because they're not bound inside the nucleus. But they used to think that positive charges were what moved, not negative. And it's only more recently they discovered that it's the negative charges that are actually moving. However, there are some cases when we do get positive charges that can flow, when you have a solution containing positive or negative ions. Okay, so that if you have positive ions, then you can flow. But that's only in a solution. So really, this situation doesn't happen for electric current. Means then is because current is defined as the flow of positive charges, okay, whether it's positive charges moving in a wire, which almost never happens, okay, the current would be in the direction that they move. So when we talk about the direction of current, most of the time the electrons move, so they're going the opposite direction, right, because they won't move in the same direction a positive charge would move under the same field. So just remember when we start talking about the direction of current that the electrons will be traveling physically in the opposite direction. So when we talk about electric current, we can calculate it. We use the variable letter I. Okay, so I, we can't really see that. Let's go to red. I means current. Okay. And it's the charge passing through a given area in a certain time interval. So it's the change in charges, or the total number of charges, divided by the time it takes for them to flow through the area. The unit of current, okay, so I is the variable, but the unit is the ampere. So we'd say that 1 ampere is equal to 1 coulomb per second. So now as we go forward, we need to understand what an electric circuit is. Okay, and we're often shorten this to just be circuit. That's why I put this in bold here. Okay, but an electric circuit is a closed loop, but it must be closed for it to work. Okay, with an electric field that causes charges to move through the loop. So we are working with this a little bit in lab, right? So this here is a switch. It allows us to close the loop, and we've got a battery that creates an electric field. Okay, and we've got something else in our circuit that is called a load. Okay, and this is what the current goes through to do something. Okay, so in this case, it's a light bulb. Okay, so when you close the circuit and you close that switch, okay, then the current or the charges can move, which creates a current that flows through the circuit. Okay, so just remember it's important that it's a closed loop, okay, and that we've got something that is an electric field that creates this, the force for the charges to move. So now we can talk about the next one, which is resistance. And resistance is the opposition presented to electric current by a material or device. Remember, opposition comes from that word opposite. Okay, so really more simply we could say that it's how hard or easy it is for charges to move. So again, we've got a charge and we're moving, but it could move really easily and fast, or it could be really difficult to move, and it could move slowly. And it just depends on the material and a few other factors that we'll look at in the next video. Okay, but this is what resistance is. So most materials are either conductors or insulators, okay? But the reality is that the amount of resistance they have is variable. So if we look at this example, we've got the same battery creating the same electric field, causing charges to move through it. Okay, but depending on the different resistance, okay, you have something 3 ohms or 6 ohms, and we'll look at what that means in a minute. Okay, for a light bulb, that's going to change how bright it is. Okay, because something with 3 ohms, it's easier for the electrons to move through, so a lot of them flow through really fast. Okay, so a low resistance means the electrons move fast. Okay, and so a higher resistance here, like in this example here, higher resistance. Okay, the electrons will flow more slow. Okay, and so you end up with a much less bright light bulb here. Okay, so we can actually calculate our resistance, and a resistance is just the potential difference divided by the current. Okay, we use the letter R, which makes sense, R for resistance. And the unit is the ohm, and we use this here, this symbol here is the Greek letter omega, and we generally draw it by you start on the left side, come up and around, and draw to the right. Okay, so that is the Greek letter omega. Okay, and the unit is the ohm. So we're going to learn a little bit more about resistance in the next video, so I'll see you guys there.